Cool. All right. So today we're doing data visualization. Again, I want to reiterate, not a main topic in our, it's not a topic in our curriculum. So I will be squishing both SQL sessions to tomorrow because I do want to talk about visualization. I think that there are some little nuances that I want to mention. So to start, just the motivation for doing visualizations. Can we really tell or discern patterns just by looking at data frames, right? Some people might argue, and I actually was one of these people as well, like, why have a picture when you can have like the numbers just straight up, telling you what these are? Like, I can do a data frame dot describe and figure out, the mean standard deviation. All I need to know, I can do my statistical tests. Next phase, we're going to be going into stats more. And I was like, why is visualization so important? Take a look at this really neat visualization here. So there's what's known as an Anscombe's quartet. So this picture over here, and this as well. But this Anscombe's quartet, actually pretty neat, that these four scatter plots look different, but they actually have the same descriptive statistics. So they actually have the same mean, same standard deviation, same covariance even. But if I were to do a data frame dot describe, these would actually all look the same. So very, very interesting that they can look kind of different. An even more fun one, I like this one called the Datasaurus dozen, where you have this dinosaur scatter plot. And it's actually the same mean for X and Y, standard deviation for X and Y, and correlation across all 13 of these images. So if I were just to do a df.describe, I wouldn't be able to know that these are actually very, very different, very, very different distributions of data. So because of this, I do think now that it is important to sometimes visualize your data just so you can get like a greater picture of what's going on. All right. So there's two main kinds of visualizations. The way that you code visualizations is exactly the same, regardless of what the visualization is for. Like we'll get into syntax a little bit more later. But why you're using visualizations and your motivations for using the visualizations, I would categorize into two main categories. One, exploratory data analysis. This is actually a process that is in every single data science project that we're going to do, shortened to EDA. I'm going to be calling these EDA graphs from now on. Is really to just explore the data that you have. So far in your data sets, I don't think you're working with anything greater than like 1,000 rows yet, but you soon will. And EDA is very, very useful to help you understand the data that you have, the data that you're given, to find out more about what you're working with. And maybe that can help determine, what models you'll be building in the future or how you want to continue analysis. In EDA, most of the time, we're trying to look for patterns and relationships. The next bucket of visualizations is explanatory data visualizations. This is just to explain and further the narrative that you're trying to bring across to important people. So for any stakeholders, if for anyone who's looked ahead to our phase 1 project, our phase 1 project is going to be an explanatory data visualization project. Basically, you're going to be given a bunch of data. You will have to explore it. So you're going to have to be making a bunch of EDA graphs to just understand the data for yourself. But part of this assignment is you're going to be asked to come up with some actionable insights for a business case, for a company. So this explanatory data visualizations will be used to convey whatever narratives you have, your takeaways and your insights. I will say in terms of when you're presenting your stuff, of course, for explanatory data visualizations, it's a lot more important how it looks. I'm going to make sure that you're going to have like all your titles, your axes labeled. Your graph should look as clear as possible. Whereas for EDA, it's a little bit less important unless you're using EDA as part of your presentation as well. EDA graphs, a little bit less about, clarity. It's more for yourself to understand your data. So EDA is for yourself. Explanatory data visualizations are for other people to understand what you are trying to get across. So main reasons for doing visualizations. All right. Okay, I might have to pip install this again. Hold on, let's hope that this runs. Okay, perfect. I was having some computer issues earlier today, so. Okay, so there are a few libraries that can do visualizations. I think in the pandas topics, you've seen that within pandas, you can do like df.plot, and you can plot many different kinds of visualizations straight out of pandas. That's actually very, very useful because, you don't have to like set up a whole nother graph. Really interesting. The pandas library actually pulls from Matplotlib. So I'm actually going to talk about Matplotlib today. I'm also going to be talking about 2 other libraries that are interesting. And we'll get to them in a little bit. So for our purposes, we're just going to use the same car DF that we've been using. So this data frame about cars, we're just going to make some visualizations, and I'm going to want to talk about some of the syntax things to look out for and things that help you keep track of how you're making visualizations. So I've linked the Matplotlib documentation there. I will say Matplotlib's documentation can sometimes be a little bit hard to read. I totally understand that. I will say Stack Overflow and Google will be your good friend as you work your way through Matplotlib visualizations. Every time I need to plot any graph, I always have to Google it. So these are the most common visualizations. Line plot will just be the one that's, a line. You have scatter plots, vertical and horizontal bar graphs. Axis line actually makes a horizontal line, vertical line makes a vertical line, and stack plots. Stack plots are basically, when you have like a bar graph, but then like different categories, so it stacks on top of each other. Those are stack plots. I want to talk about the syntax of Matplotlib and what you're actually doing here. So to quickly run this, we have plot.scatter. So PLT comes from the alias of matplotlib.pyplot. So basically what this means is within the Matplotlib library, there's kind of like a folder known as pyplot, and we're using things out of pyplot, which is why we're aliasing this whole thing to be PLT. This line here is specifically for notebooks. It helps your graphs render better. I believe if you don't have this, it's not a big deal. But for some computers and some systems, if you don't have this line, it won't render nicely on your notebook. All right, so how this works, how plots work. Whenever you start with plt.something, it can be scatter, it can be plot, any of these. What it does is it sort of creates an object or creates a canvas automatically. And then it plots your points on this canvas. And all of these subsequent lines add to that canvas. So that's how I like to understand how the syntax is. Like, why am I doing so many lines of plt dot blah, blah, blah? It's because you're continuously adding things onto a canvas where your visualization lives. So this first line starts off our canvas with this scatter plot. Still missing a lot of elements, especially if you were to present this to someone. Someone will be like, okay, I see a bunch of dots on this page, but what is this? So first, we're going to add our title. And by the way, if I haven't told you all yet, command or control question mark, comments and uncomments lines. You're going to be probably using this a good bit. So let's add these one by one. We add a title, title relationship between displacement and horsepower. Cool. We should also always add axis labels. So we'll have our displacement and horsepower there. Sometimes you need a legend, sometimes you don't. In this case, the legend is automatically that this is car because label equals to car here. And then finally, this last line of plot.show. See, I wonder if y'all can see what's going on here. So you see how this like Matplotlib legend comes up? This is because by default, Jupyter Notebook just returns you the last line of whatever you have, right? So before I had the legend, I had like the X label. So when I ran this, you see how it was like text, blah, blah, blah. So because of that, the last line is always being output by notebook. So the plot.show just kind of cleans that up. So therefore you're just showing. It's kind of equivalent to like a print statement, where sometimes you need a print statement, especially if it's not, the last thing in a cell. Think of it like that. It kind of also cleans up the way your notebook looks. So plot.show just gets rid of that, whatever this output is. So that's good to know. So every time you're doing plot.something, there's a lot of things that you can add onto a graph. Plot.something, this is just known as like adding attributes to your plot object. Yeah, technical terms, that's what that's what that is. All right, so this is a pretty straightforward, just a single graph. I know that in the pre-work, there's also subplots, and subplots, the syntax for that can be pretty confusing as well, because we have this special subplots syntax. So let me run this just so we can see what we're working with. So here we have some histograms. We have two graphs showing just the distribution of your weight and your year. There are actually a couple different ways to do subplots. I do think that this is the easiest one, and I'll show you all why. What is happening here with the fig and the axes? If you remember fig and axes, and let me run this first. If I run this by itself, it's going to just create two different things. You're assigning things to two different variables. So before that, actually, let me see whether this will help. Cool. When I output this, look what outputs. It says there's kind of a tuple, which is why we're doing the unpacking there. If you don't remember what unpacking is, it's the fact that we can, assign two different variables at the same time. So X and Y. If we do that, X is X and Y is Y. So that's the whole unpacking thing. So plot.subplots, and actually let me grab the documentation to show you all real quick. Subplots. Cool. So in plot.subplots, it outputs, see here, it outputs two things, a figure and an axis, which is an axis or an array of axes. So we'll break this up a little bit more. When I just have plot.subplots, it outputs like a tuple here where I have like my figure with two axes. And you see here, it's actually an array with two subplots within it. So it kind of matches up to what we want. I just know it's kind of sometimes confusing when it's like returning multiple things. You just have to like read the documentation and know that there are two things being returned here. I did fig and axis. So let's take a look at what fig is. Fig in this case is our canvas. It's just our blank canvas that we're going to keep adding things to. So here when we have fig and axis. And what is axis? You can see the axis is actually an array of two axes objects. So when I did plot.subplots 1, 2, it basically means 1 row, 2 columns. So if I expand this to maybe like 3 rows and 2 columns, and I run that, you see that it makes 6 empty graphs because I haven't added that information yet. And if I run axes again, you can see that there are 6 graphs there. And since this is an array, you can actually index through these. So if I do like axes, let's see, axis 0 is the first row. And let's say I want to do the very first graph. The first graph is this single subplot. So something I can do is, let's say I want to add a histogram to just this first subplot. I can actually make use of this. So I can say maybe like, okay, histogram of my car DF, I don't know, miles per gallon is one of them. You can see that is there. When I rerun, ooh, that's not gonna work. Hold on, I have to put this together with this. There we go. When I rerun that, it throws that histogram in there. So I think it's important to understand, like when you're creating a thing of subplots, that's actually what's going on in the back end. I know that there are different ways of doing it. You can actually do like axes.flatten. Axes.flatten is pretty neat as well. So let's say you want to loop through all of your subplots. You do axes.flatten. I forget if there's a, there we go. If we do an axes.flatten, what has happened is instead of having like a 3 by 2 like this, it kind of turns it all into one long list. So it's easier to loop through. So I know in some, I think in some syntaxes, you might see axes.flatten as people try to add different graphs in different places. But in the backend, it's really just an array of axes that you're adding things to. All right, so now that we hopefully kind of understand a little bit more how these subplots are working, let's see how we can build this up. So when you're thinking of adding stuff to a figure with subplots, you have to think about what is a figure attribute and what is a subplot attribute. So figure attribute being something like this. The super title, subtitle, which is an attribute of the entire canvas. So this title will be for the entire canvas. Therefore, instead of axes.something, I do fig.subtitle, super title, subhistograms. So this is an attribute that works on an entire figure. Alternatively, for each of these axes, what's kind of annoying about Matplotlib, and I I feel like it's fair to say it's kind of annoying to, this is kind of annoying because the syntax is slightly different and inconsistent when you're doing an axis within a subplot versus if you're doing a plot like this. So remember how we did this? We were doing like plot.x label, plot.y label. That's how you add your labels. For this, it's dot set. X label equals weight, Y label equals frequency. It wouldn't be axes dot X label equal what, axes dot Y label equal what. It's just different. And honestly, I would not remember the syntax. I would Google it and just figure it out from there from examples that you find on the internet. So what we're doing here, because if you remember, let me rerun this one more time. If I rerun this, my axes is just 2 axes here. Therefore, I can actually index them 0 and 1 to just decide like which one I want to put where. And that's how I decide, okay, I'm going to put a histogram here for my weight, histogram here for my year, and then show that. I do want to talk a little bit more about unpacking. So let's talk about this fig and axes. Fig and axes, we have plot subplots here. We know that our axes at this point is our 2 subplots, right? Something that's really neat is you can actually do, you can actually really take advantage of Python's unpacking. If you do fig comma and do like x1 comma x2, and then you, let's say print x1, x1 will refer to the subplot. So instead of doing, you know, the index here, I could do this, dot his dot set, blah, 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 x1. Oops, get rid of this as well. There you go. So this is another way to make use of the unpacking even more, to directly set each axis. So that's pretty neat to know. I think it's more about understanding the structure of how, you know, these different things work. So I think with Matplotlib, subplots is probably the most confusing part. I know in one of the pre-work labs, if y'all remember, has you do like a gigantic subplot visualization. And they actually have you like, you know, loop through like the row number and the column number. That's probably one of the more complicated ones. I actually will argue that if you find that you're making like a graph with subplots of like more than maybe like 10 graphs, it sort of loses how useful it is. It loses usefulness for explanatory visualizations. Unless you're trying to get someone to see picture as a whole, I don't recommend having so many things in one figure. So that's just my 2 cents. Okay, so basically I wanted to show you all the mechanics behind how subplots are actually formed. Questions about this before we move on to other libraries?
What does Sherry stand for?
Sherry, it's share Y. So this is sharing the Y axis. So the frequency won't be labeled twice, I think, or something like that. Yeah, I think if we take a look at subplots, it will say whether they will share properties among the X or Y axes. Anything else? Cool. So the other library that is talked about is Seabourn. I'm only going to quickly talk about Seabourn. I hope I have Seabourn. Yeah, I broke my computer. If anyone is on a Mac and decides to upgrade your OS, let me know, because you might run into this problem as well, where all your libraries get deleted. I also like tried to mess with it myself, so it's my own fault. Okay, so with Seabourn, Seabourn is actually preferred for more recent students. Seabourn is actually a library that is newer than Matplotlib, and Seabourn is actually built off of Matplotlib, which is pretty cool. So a lot of Seabourn graphs are basically Matplotlib graphs, but Seabourn has abstracted a lot of the code, so you don't have to like manually code in nice colors or specific kinds of graphs. So this is just some sample data. We take a look at what this data looks like. It's just an array of random numbers, honestly. One of the graphs that Seabourn does a lot nicer than, a lot more nicely than Matplotlib does is box plots. And you can see here the colors by default are already nicer than the Matplotlib ones. let me move this over here. And you can see that here we have our Seabourn graph. Seabourn has a much better documentation in my opinion. In their documentation, they also have a good number of examples. And Seabourn is slowly taking over as the visualization library of choice. So I just really wanted to quickly show this. I think you have to do a boxplot.show. I forget. Let's see if this works, or is it not .show? Yeah, I forget which one it is for Seabourn. Because Seabourn actually came out after I graduated from this program. I actually don't use Seabourn that much, but a lot of students like Seabourn. The colors are just by default nice. So you can set palettes, you can set like specific color gradients that you want. So yeah, I just wanted to mention that Seabourn is actually built off of Matplotlib. Any questions about Seabourn? Awesome. Well, I do want to introduce one more library. This is actually my library of choice. It's known as Plotly. I hope I have this library. Okay, let me just quickly do this install. If you ever get a module not found error, you can always just do pip install, whatever it is, Plotly. Okay. So this hopefully won't take too long. But this is my visualization library of choice. I think that this library has the nicest documentation as well, a lot of examples. And another reason why I think this library is a good idea to use is because one, it is built off of D3. D3 is actually one of the biggest JavaScript plotting libraries. So it is to some extent kind of language agnostic. Also, if you're interested in dashboarding, if you're interested in like building dashboards in the future, Plotly has a direct to dashboard syntax. So in the future, I'm going to be talking about dashboarding way later in this course. Yeah, if you're making your Plotly graphs into a dashboard, it's just a matter of copy paste in a bunch of different places. So I personally like Plotly a lot. I'll also show you why I like Plotly. It's because of, let's see. Oh no, hold on. Let me pip install this again. Install stats models. All right, hopefully this won't take too long. Let me just do a really quick example. px.scatter. I think this will work on its own. Where is it? Okay, let's not worry about that for now. But wait, let me run this again. I really want this to work. Okay, cool. I don't know what that is, but this is what a Plotly graph looks like. And what I really like about it is you can hover over and it's interactive. I think it also looks nicer by default. So Plotly, I forget what I did here. This is not relevant right now, but basically you can see that it actually pulls from the data frame. You can tell it what your X and your Y is. You can give it your title, your hover data, which is really neat. You can see that my hover data, whenever I hover over a point, it'll tell me the car name and the model year, which is always sometimes good to know. And then I can add this trend line here, which you can also do in Seabourn, but I personally like this one a lot better. I honestly don't care what library you use. I just want to tell you all that there are these options. And I understand that like in our program, Matplotlib and Seabourn are used the most. I personally like Plotly. I do think it's a good idea to be exposed to different libraries for visualizations. But yeah, this is just an example. Plotly's documentation is also really nice and clear. If I do Plotly Express, let's go here. Hold on. px scatter. They have this documentation, which is nicer. You can see that there are a lot of examples that you can see how you can, bubble charts. You can even dashboard it. So this is just an example of how you can dashboard your Plotly graphs within your notebook, which is super neat. And yeah, a lot of different kinds of plots that you can do here. Bunch of plots. So I like to plug Plotly to students just so that, you get to see it at least. But it's really up to you at the end of the day it's up to you what library you use for your visualizations. I would say because now we're in a fast-paced bootcamp program, pick one and stick with it. But yeah. Cool, awesome. Well, that was faster than I expected, and that's all I had to share for today. Does anybody have any questions regarding anything that we've talked about or anything that's coming up? All right, well, if there's nothing else, I will see you all tomorrow. We're gonna talk about SQL tomorrow. Feel free to Slack me with any questions. With SQL, I'm going to be just going through some SQL querying basics, as well as show you all some places where you can practice more SQL. And I'll talk also about like how SQL is used in the context of data science. So look forward to that. For SQL, my notebook does have a database that it connects to for tomorrow. So I do recommend if you want to follow along with the code, you should make sure that your study group repos are up to date. And feel free to Slack me if you have any problems with that. All right, well, with that, have a good rest of your Thursday, everybody. I know we ended a little bit early today, but that is okay. Feel free to let me know if anyone's having any issues. Don't forget that assignment. I'm kind of loose on due dates, hopefully due tomorrow, but if you do it over the weekend and submit to me on Tuesday morning, I'm okay with that as well. All right, well, have a good rest of your day, everybody. I'll talk to you all soon. Bye.